Alright, in part one, you learned a little bit about the hydrophobic and hydrophilic of hemoglobin. So now we're going to look more into hemoglobin. So hemoglobin is made up of four sections. Oh, let me change the color so you can see it here. Oh, I just need to change pens. Alright, so we have one, two, three, 4 units in one hemoglobin molecule. So this is just one hemoglobin molecule. There's 4 units. And there are heme groups in there. Alright, so this is the responsibility of carrying the oxygen. These things right here carry the oxygen. But we're not too worried about that right now. But that contains the iron and carries the oxygen. So now let's look at our glutamic acid. So let's erase these here. So there's two key glutamic acids, and this is a normal hemoglobin that has glutamic acid in it. And there's two key ones. There's ones right here and right here. Alright, you notice how they're on the outside of the molecule. Alright, and this is going to be important because of what we'll see in the next section. So we have 4 sections, and this is on the beta chain. So remember, these are the alpha, these are the beta. Again, not too important. The key thing is where these glutamic acids are on. They're towards the outside of hemoglobin. So now if we go to part 2, let's see where my page, there we go, the button was covered up. Alright, so now part 2, this is showing sickle cell. So normal hemoglobin, let's talk about normal hemoglobin first. So normal hemoglobin would not do this. We have, instead of, so this is showing the valines. So there's valines right here on the hemoglobin. So there's 1, 2 on this one, 1, 2 on that one. And what it's showing here is where those, so these are the mutated sickle cell. And what they're doing is they're sticking to this hydrophobic pocket here. Alright, so this is hydrophobic, and remember, valine is hydrophobic, so they stick. Remember what we just talked about? So they stick together. But if we go back out to the start here, reset position, there we go. So if we do this, these two hemoglobins, this was normal hemoglobin. Instead of valine, those would be glutamic acids, and these would repel each other. Alright, instead of the glutamic acid binding to a repel, and these guys would be separated, and the hemoglobin would just float around freely. So if this was a hemoglobin all around the cell, the hemoglobin flows freely. Alright, and that allows the cell to be a circle, because the hemoglobin is just floating around in the cell. Alright, but in sickle cell, if we look closely at this, come on, we have, let's zoom into just our hydrophobic pocket here. In our hydrophobic pocket there, if this is valine here instead of sickle cell, instead of glutamic acid, valine is hydrophobic, and this is now hydrophobic, so they stick. Alright, they stick together, so they both want to come together and stick together. Alright, so if we have that, and if we go back up here, and show that they're sticking together, and then if we show all the glutamic acids where they got mutated to valines, there's one up here, and there's another one somewhere, but oh, here it is. So now if other hemoglobins came, this hemoglobin would stick here to the pocket, the hydrophobic pocket would stick there, hydrophobic pocket would stick there, hydrophobic pocket would stick there. Alright, so they start running into each other and start sticking. Alright, because this valine is hydrophobic instead of hydrophilic. So instead of repelling each other, they stick together. That's the basic main concept that you need to get. So hemoglobin, the mutation caused glutamic acid to go to valine, which change hydrophobic to hydrophilic. So then, if we look at our sickle cells down here, this is what it looks like. So in our round cells, the hemoglobin is just, let's get blue for hemoglobin now. Our hemoglobin is just floating around. Those glutamic acid are pushing those hemoglobins apart so it can become round. But if you look here, on this side, this is sickle cell and this is sickle cell here, those hemoglobins stick together and they form these stiff rods. Alright, so here's a whole bunch of, and then here's a whole bunch of bundled together. So these stiff rods then show up like this. There's one there, there's one there, one there, and that causes the cell, instead of it to be flexible and go around, it causes it to be rigid and stiff and form this sickle shape. Alright, so it's all caused by that valine causing those hydrophobic pockets of hemoglobin to stick together. Alright, so that's what you need to get out of this section.